In the Chapter 11 intro notes, all they're trying to get us to do or to think about in this particular section is how two numbers would relate to each other. If they gave us a little piece of information, could we figure out which number is bigger or smaller? Or if we do know which number is bigger or smaller, what happens when we work with them, when we subtract them, for instance, okay? So in this case, they're going to say, hey, A minus B is a positive number. So you know that A is blank compared to B. So we're either going to put an equal sign or an inequality symbol in that blank to make a true statement. Now, inequality symbols are the greater than symbol or the less than symbol. And a lot of times people know which one to write, but they may not know which way to say it. So remember, the inequality symbol always opens to the big number and points to the small one. You could think of it like a bully that's pointing at the little one. Okay, so if I had the numbers maybe 5 and 3, 5 is greater than 3. It's going to open to 5 and point to 3. If I wrote it the other way, where 3 on the left and 5 on the right, I would say 3 is less than 5. So either way you write the numbers, it's opening to the 5 and pointing to the 3, but the way you phrase this symbol is different. If you write it this way, you would say greater than. If you write it this way, you would say less than. Okay? So what if they didn't tell you the numbers? They just say, hey, A minus B is positive. Okay, well, let's see. We've got to create numbers for A and B so that when we subtract them, we get a positive number. So maybe it's 8 minus 3, because that would be a positive number. 8 minus 3 would be positive 5. Or maybe it's 15 minus 11. Well, 15 minus 11 would be a positive number. It would be positive 4. So if you notice in this case, since these both work out to be positive numbers when you subtract, notice that the big number was first. 15 was bigger than 11. 8 was bigger than 3. So it must be that A is greater than B. On the other hand, if A minus B is a negative number, what do we know about A and B? Okay, so let's subtract two numbers so that we get a negative. So maybe we say 2 minus 7. Well, 2 minus 7 is a negative number. It's negative 5. Or maybe it's 3 minus 4. Well, 3 minus 4 is a negative number. It's negative 1. So in order for the subtraction to work out to be negative, the A number must be smaller than the B number. The A number must be less than the number that comes second. We did small minus big. Okay, so A is less than. Okay, same idea here with C and D. Okay, only this time they're giving us the statement of which one is greater than or less than, and we have to figure out what the subtraction is going to work out to be, positive or negative. Okay, so here they tell us C is less than D. C is the small one, D is the big one. Okay, well, if C is the small one, then when you do C minus D, you're doing small minus big. And small minus big is going to work out to be negative. On the other hand, let's see, D is less than E. So D is the small one, E is the big one. So when we do E minus D, E was the big one. We identified that B was the big one. I'm sorry, E was the big one and D is the small one. So when you do big minus small, you're going to get a positive number. So they're just trying to have us think about, hey, you know, should this answer come out positive or negative? Which one's bigger or smaller? They're having us think that through. Okay. 5, they change gears a little bit here. There is no difference between the mean grade in Class A and the mean grade in Class B. Okay, so mean like the average. So the average grade in Class A and the average grade in Class B, there's no difference. Well, if there's no difference between them, that must mean they are the same. Okay, if there's no difference between them, they're not different. They must be the same. They must be equal to each other. So that says we know the mean of Class A equals the mean of Class B. Okay. Another way to think about it is when you did the difference, when you did A minus B, because difference means subtract, when you did the difference, you got 0. Well, a difference of 0 means that A and B are the same. Okay, if there's no difference, that means when you subtract them, you get 0. If there had been a difference, we would have gotten either a positive number or a negative number once we did the subtraction. Okay. All right, number 6, 7, and 8, changing gears just a little bit, but it's still a similar idea. We're thinking about the relationship and the difference between two values. So number 6, they tell us we know that the difference, A minus B, is between -4 and -5. Okay, so let's pretend we had a number line here. I might have, these are negative numbers, so I'd have maybe -4 here, -5 here. If I went further to the right, I'd be at -3, -2, -1. I'd eventually get to 0 in the positives. If I went to the left of -5, I'd be at -6. So they're telling us that when you do the subtraction, when you work out A minus B, you get something in between -4 and -5. We don't know exactly. It might be -4.2. It might be -4.7. We don't know exactly what it is. We just know it's in between -4 and -5. Well, if it's in between -4 and -5, that means it's guaranteed to be negative. And what did we learn happened if your difference was negative? We said up here that if your difference is negative, the first number must be the small one. Okay, so if our difference works out to be negative, then A must be the small one. We must be taking the small one minus the big one in order for that difference to work out to be negative. So which is larger? B. B is the large one. And an inequality statement comparing them, well, if B is the large one, then we could say A is less than B, or you could flip it around. You could say that B is greater than A. Either inequality statement would work, but you have to indicate that B is larger. So the inequality symbol has to open up to B. All right, number 7. We know the difference A minus B is between 2 and 3. So if I picture a number line, we've got 0, 1, 2, 3, 4, 5, etc. The difference is between 2 and 3. I don't know what number it is. I don't know if it's 2.3. I don't know if it's 2.9. I don't know exactly what the number is, but I know it has to be in between 2 and 3. Well, if it's got to be between 2 and 3, it's got to be a positive number. Okay? So if it's the subtraction problem is working out to be a positive number, then the number they mentioned first must be the big one. So in this case, A must be the big one and B is the small one, because when we do A minus B, we get a positive number. So A is the larger value. So for an inequality statement, we could say A is greater than B, or you could say B is less than A. Those would both be true inequality statements. Number 8, we know the difference of A minus B is between -1 and 1.5. All right, if we look at a number line, -2, -1, 0, 1, 2. Okay, so we know it's in between -1 and positive 1.5. So it's somewhere in this range here. It might be that A minus B is -0.7. It could be that A minus B is 1.2. But it's got that difference. When we work out A minus B, it comes somewhere between -1 and positive 1.5. So really, we don't know whether it's positive or negative. In fact, A and B could be the same number, so that A minus B works out to be 0. That's even in play. So which is larger, A minus B? We don't know. In fact, they might even be equal to each other, because when you subtract them, it could come out to be a positive number like 1, or when you subtract, it could be a number like -0.7. We don't know. So can we write an inequality statement comparing A and B? And the answer to that is no, because we do not know which one is bigger and which one is smaller. Okay. Number 9, they ask us to solve an inequality for mu1. Note this little symbol, mu1 and mu2. So mu1 would be the mean of data set 1. Mu2 would be the mean of data set 2. We do not have the data sets. We do not know what the means are actually worth. Okay, but whatever the mean of the first group is, minus whatever the mean of the second group is, apparently that works out to be less than 0. That's what less than 0 means. Must work out to be negative. Okay, if it works out to be less than 0, that's a negative number. Okay, well, the only way that you can subtract two things and get a negative number is if your first one was smaller and the second one was bigger. They must have done small minus big for it to work out to be negative. So when they say which one is larger, mu1 or mu2, I'm going to say mu2. mu2 had to be bigger. Okay, so I'm able to answer the question of which one is larger without actually solving this inequality. But when they say solve the inequality, they're saying, hey, get the mu1 by itself. Okay, well, if I want to get mu1 by itself, that means I got to get rid of mu2. So I would add mu2, because that's the opposite of subtracting it. So when I add mu2, that would leave me mu1 is less than mu2. Well, yeah, we already know that. We said mu1 was the smaller one, mu2 was the larger, so yeah, mu1 is less than mu2. So you could think about that either way. You could solve the inequality to get mu1 by itself, and it tells you mu1 is less than mu2, so you know mu2 is larger. Or you could have just, kind of thought it in your head, hey, if mu1 minus mu2 is less than 0, that means it's negative. That must mean mu1 was the small one. They must have done small minus big. So either way you want to think about it, you're going to come up with that same conclusion. And then the last one, solve for P1. Remember, P is our symbol that we use for proportion, probability, okay? And when we use regular P, we're talking about a population. When we use P hat, we would be talking about a sample. So these must be two population proportions. 40% of all people like chocolate chip cookies. 70% of all people are fans of the Dallas Cowboys, whatever the case may be. So they want us to solve for P1. Okay, so they want us to get this P1 by itself. Well, if we're getting P1 by itself, that must mean that I'm adding P2 to both sides. So P1 must be greater than P2. So which is larger, P1 or P2? P1 is larger. Now, if you wanted to think about it without solving the inequality, when they say P1 minus P2 is greater than 0 would be a positive number. P1 minus P2 must be a positive number if it's greater than 0. Well, when you do subtraction and you get a positive number, that must mean your big number was first. So P1 had to be the larger value. So this intro to Chapter 11, it's not really a lot of problems to work. It didn't even have any numbers, really. We were just trying to think about the relationship between two values and whether the subtraction came out to be positive, negative, and if the subtraction worked out to be positive, we knew the big number was first. If the subtraction worked out to be negative, we knew the big number was second. And if the subtraction works out to be 0, we know the two numbers are the same. If the subtraction worked out to be, a range from negative to positive, then we don't really know which one is bigger, the first one or the second one. That's going to come up as we work in Chapter 11 with some more hypothesis test problems. So we just want to kind of think about this relationship between numbers.